Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 17, 2025, just yesterday. The striking result is that this paper introduces the P1 family of physics-focused large language models, trained purely with reinforcement learning, and one of them becomes the first open-source model to win a gold medal at the International Physics Olympiad 2025, collecting 12 golds across 13 major contests. The paper is titled P1, Mastering Physics Olympiads with Reinforcement Learning, and as we will see later, the implications for science-grade reasoning are pretty remarkable. Also, the authors shared an open GitHub repo for P1. There you'll find a detailed README explaining the two released model variants, their Olympiad and STEM benchmark results, and a clear description of the PhysicsMinions multi-agent reinforcement learning pipeline, along with docs that walk through how to use the models in practice. Figure 1 shows that these reinforcement learning-tuned physics models actually reach top human Olympiad performance. The bar chart compares exam theory scores at the International Physics Olympiad 2025 across many open-source and closed-source systems. The combined P1 235BA22B with PhysicsMinions agent scores about 23, which ranks first overall. The standalone P1 235BA22B sits solidly in the gold medal band, while the smaller P130BA3B lands in silver territory yet still beats most other open-source models. Figure 2 shows how the training problems spread across branches of physics, which tells us what kinds of reasoning the model practices most. The largest slice is mechanics at about 41%, followed by electromagnetism and thermodynamics, with smaller shares for modern physics and optics. This means the model sees a particularly deep diet of core contest topics, like forces, fields, and heat, so its strongest skills should lie in these foundational areas. Table 1 spells out how large and rich the physics training corpus really is. The dataset includes about 5,000 problems, most drawn from real Olympiads rather than textbooks. There are roughly 7,000 worked answers, which means the model repeatedly sees full step-by-step reasoning. The problems span 5 major fields. They also cover about 25 subfields, giving broad coverage inside each branch. And token statistics show that each question and solution is several hundred tokens long, so the model must handle extended multi-step arguments rather than short snippets. Table 3 makes the medal story concrete because it shows exam scores for every major model across 13 recent physics Olympiads. The main grid summarizes each model's score on every contest and its average, compared directly to human full marks and medal cutoffs. This layout reveals that P1 235BA22B and its PhysicsMinions version consistently sit in the gold region, matching or beating leading closed-source systems. So while Table 3 made the medal picture on physics contests clear, Figure 6 shows how those same models behave on broader reasoning tasks. The paired bar charts compare P1 against the Q1 base models across mathematics exams, science and engineering questions, coding, and a general reasoning benchmark. In almost every case, the purple P1 bars stand taller, which means higher accuracy. The gains are especially visible on harder math sets and on the science, technology, engineering, and mathematics evaluations, suggesting that focused physics reinforcement learning actually sharpens reasoning skills far beyond physics itself. Alright, the big takeaway is that focused reinforcement learning, plus automatic verification, can push open physics models to true Olympiad gold level and even strengthen math and coding skills. More broadly, this hints that science-grade reasoning models might soon become routine research partners. That is it for this episode of AI Research Roundup. I am Alex. Thanks for listening.